Hello and welcome to Aditya classes, where we have been discussing about assignment problems these days. Now today we take up a problem where we will try to minimize the assignment problem. We will try to look for a solution which is minimizing the total cost of this problem. But when we go ahead and try to solve this problem, we see that there are 1, 2, 3, 4, 5, 6 factories and A, B, C, D, E, 5 markets. Now this is a case of an unbalanced problem. Why unbalanced problem? Because in an assignment problem, number of rows should be equal to number of columns, number of sources should be equal to number of destinations, number of jobs should be equal to salesmen or workers. Number of machines should be equal to number of jobs. Number of salesmen should be equal to number of territories. If there is a mismatch, someone will be sitting idle. Some task will be sitting idle, some machine will be sitting idle, some salesman will be sitting idle, some territory might go idle. So in such cases, in assignment, we should have number of sources and number of destinations, or number of rows and number of columns same. Here we have 6 rows and 5 columns. This is an unbalanced problem. How do we balance it? Now we'll try to minimize it, but first we need to balance it. How do we balance it? Simply by adding a dummy column or row. Wherever there is a lag, you can add a dummy, or rather you should add a dummy. So we have 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5. There is a lag of columns in, there is a lag in column side. There are 6 rows but only 5 columns. So I'll make 6 columns. So I have 6 rows, I have made 1, 2, 3, 4, 5 columns as given, then I have made a dummy column. Yes, in solving these kind of problems, you might come against this kind of situation also, where you have 1, 2, 3, 4, 5 rows and only 3 columns. So if there is a situation like this, where you have only 5 rows and 3 columns, you go ahead and add 2 columns. Whatever is the lag, you add that many columns. And now for our problem, we had a lag of 1 column. I've added a dummy column. If you add 2 columns, you can call them dummy 1, dummy 2. And let me transfer these costs over to my new matrix. The costs are 5, 4, 6, 7, 8, 12, 5, 4, 6, 7, 8, 12. Then there is 10, 10, 13, double 14, 18. 10, 10, 13, double 14 and 18. 2, 3, double 4, 6, 10. 2, 3, double 4, 6 and 10. Then we have 12, 14, 16, 18, 18, 20. 12, 14, 16, 18, 18 and 20. Then there is a 2, double 6, 9, 12, 12. 2, double 6, 9, double 12. And then what about values in this dummy column? There is no dummy column over here. What about values in this dummy column? I'll put a 0 over here. That is it. I'll put a 0 in my complete dummy column. So this was my table 1. This is my table 1, where what I've done, I've balanced my problem. This was an unbalanced problem. I have now balanced it. This becomes a balanced problem now. Once I have balanced this problem, now I can get on with my task. This would be my table 2, where I'll be going for row reduction. But if you have a look at table 1, what is the purpose of row reduction? To have a 0 in each row. We select the minimum value and subtract it from each element in row. You select the 0, subtract it from all elements. They'll remain same, 5, 10, 2, 12, 2. Second row, minimum is 0, you subtract it from all. 4 minus 0, 10 minus 0, 3 minus 0, everything remains same. For each row you can check 12 minus 0, 18 minus 0, because minimum is 0. So we see that in case of dummy, when we are adding a dummy column, this matrix is already row reduced. So what I can say is, I have done two things over here. This is table 1 and you can call it adding dummy column, and it is also row reduced. As it is row reduced. What is the purpose of row reduction? That each row should have a 0, each row already has a 0. So I can straight away go for, instead of row reduction, I can go for column reduction. Our next step would be column reduction. So in one table I have actually done two steps. I have added a dummy column, row reduced, already it is row reduced. Now let me go for column reduction. Column reduction is subtracting minimum in each column from all other values. In this column minimum is 4. Subtract 4 from all other values in column to get 1, 0, 2, 3, 4 and 8. Here minimum is 10, subtract 10 from all. It will be a 0, 0, 3, 4, 4, 8. Then minimum is 2, subtract it from all. You get a 0, 1, 2, 2, 4 and 8. Then minimum over here is 12, subtracted from all others, 0, 2, 4, 6, 6 and 8. Minimum over here is 2, 0, 4, 4, 7, 10 and 10. Minimum in this column is 0. So I have a row reduced matrix, I have a column reduced matrix. Each column is having at least 1 0. Third column is having this, this, this. Every column is having at least a 0. There may be more. There are 6 of those. There are 2 of those, but at least 1 0 is everywhere. Now can we go in for assignment of this? Let us go for assignment. Assignment, if you remember, there is a priority list. First is you should look for, in the priority list, first is unique 0. I assume you have seen our previous videos where we have talked about what is a unique 0, what is single 0 and what are minimum zeros. So let us see if there are any unique zeros. 4 zeros cannot be unique, 3 zeros cannot be unique. 1 0 could have been unique, but then there are 5 zeros, they cannot be unique. So these cannot be unique because multiple, these cannot be unique, these cannot be unique. So I have scanned all zeros, these cannot be unique because there are multiple zeros in rows. None of these has the capacity to be unique because they have other zeros, and neither these have any capacity. So there are no unique zeros. Then what about single zeros? 4 zeros, leave it. 3 zeros, leave it. This is a single 0. Let me go ahead and assign. You make an assignment in single 0, but then make it unique. How do we make it unique? Now if you have a look at the 0, there is no alive 0 in its row or column. So now that is unique. So we are done with third row, fourth, fifth, sixth. There are no zeros in rows. Let me go for columns. This is a single 0. Let me go ahead and assign. Column wise it is single, row wise I make it single, thereby making it unique. So it is a unique. First column done, second column I have a single 0. Make an assignment. Column wise it is single, row wise I'll go ahead and make it single. So now this 0 is also unique. Now my matrix was 6 by 6 and I'm having only 3 zeros. This is a case of degeneracy. How do we resolve this degeneracy? By cutting all zeros. In how many lines? In n number of lines, where n is number of assignments. 1, 2, 3. You have made 3 assignments, you get 3 lines to cut all zeros. They may be horizontal lines, they may be vertical lines, but you have only 3 lines to cut all zeros. What should be my choice? Obvious choice is this because this line is covering 6 zeros. Obvious choice is this because it is covering another 4 zeros. Total 5, but another 4. So 2 lines have covered almost all zeros. 2 zeros still remain. Now there is no option apart from this particular line, this horizontal line, because if you go with vertical line, this 0 will remain. So I go with this. When we are cutting these zeros, it doesn't make a difference if it is an assigned 0 or a cut 0, because this is not a valid assignment. So all these zeros have become alive once again. It is not a case that this is an assigned, this is a cut, is this a 0 or not? All these are zeros because it is not a valid assignment. So all these are proper numbers now for me. So these are the 3 lines where I have cut all the zeros. Now next step is taking these to our new matrix. What were the 3 steps? Subtract minimum in uncut. Second step is add this at intersections. I am not writing these in detail because we have separate videos which we have done in previous lectures where we have talked about degeneracy, resolving degeneracy. I'm just writing these in brief so that you can get a reminder. Subtract minimum in all uncut, add this to intersections, copy the cut cells. So these are 3 steps to transfer it to our next table. Next table would be table 3. These are uncut cells. Minimum in these uncut cells is 2. There is nothing less than 2, and there are quite a few 2's. So I'll subtract 2 from these. So making it 0. Sorry, we should make use of different color. It will become 0, 1, 0, 2 and 2. Subtracting here we get 1, 2, 2. Sorry, this is 0. So it will become a 1, 2, 0, 1, 2, 0, 4 and 5. Here we will be getting 2, 2, 2, 4 and 8. 2, 2, 2, 4 and 8. What is this step? This is first step. Subtract minimum in the uncut cells from all uncut cells. Okay, we have these also. So it will become a 6, 6, 6, 6 and 8. This is our new. So subtract minimum in uncut cells. I have done. Add this value, that is 2. The value that we have subtracted from everywhere. Add this value to intersections. There are 2 such intersections. I'll add this. So 0 plus 2 would become a 2. 0 plus 2. This is also an intersection would become a 2. And then third is copy the cut cells. All these remaining cells are cut cells. Let us copy them. We get a 1, 0. Then there is a 0, 0, 1, 2, 4. 0, 0, 1, 2, 4. Then there is 1, 2, 3, 4 zeros. So what I have done, I have tried removing the degeneracy. Let us see if it has been removed or not. We'll go for a quick assignment. 4, 2, 3 zeros, 2 zeros. None of them are unique. All zeros are having some partners in either rows or columns. All these 4 are checked because they have partners in rows. These have in columns. Everybody is having zeros as partners. So there are no unique zeros. What about single zeros? 4 zeros, 2 zeros, 3, 2. This is a single zero. If you get a single zero, make it unique. One assignment is done. I've scanned all rows and only one assignment has been made. Let me go for columns. 2 zeros, 2 zeros, 2 zeros, 1 zero. This was a single in its column, make it single in its row. Remove all zeros in its column. I made this assignment, removed all. So this is an important step. When you make an assignment in a single zero, remove all other zeros. Now we are through with all rows and columns, yet there are certain zeros. So let me scan rows. 0, double 0, double 0. This now has become single 0. Because there was a 0, but now it is removed. Now it is a single 0 in its row. In its column also it should be single. So I have removed this 0. Now it is unique. Single in its row and column. No zeros in rows. For columns there are 2 zeros. Now this one has become single. So I can assign it and remove this. All columns are done. There are no zeros over here. If I move to rows, this is a single 0. In fact, this has now become unique. Why is it unique? There are no alive zeros in its row, no alive zeros in its column. Is this a feasible assignment? 1, 2, 3, 4 and 5 assignments. I need 6 assignments because I have 6 sources. So again, this is a degenerate solution. I need to remove this degeneracy. How? Now this time I have made 1, 2, 3, 4, 5. I have made 5 assignments. So I get 5 horizontal or vertical lines to cut all zeros. Remember, these are also zeros, these are also zeros. Because this is not our final assignment, so all these zeros are once again alive. This was only my checking. All these zeros are once again alive. This is also 0. You need to cut all these zeros. So a good starting point would be cutting 4 zeros in one shot, another 4 in one go. Then you can take these 2 in one. You can take either ways. I have used 1 line, 2 line, 3 line. I have still 2 more lines. So let me go ahead and make use of any lines. You can make use of either of these lines. So 1, 2, 3, 4 and 5. I had 5 lines, I have cut. Quickly, I'll go through these steps. The uncut cells are this group and this group. And the minimum here is 1. So I can subtract 1 from all these. Getting a 0, 1, 1, 1, 5, 5. I'm subtracting 1 from all. 3, 4, 3, 7, 5, 7. Done? Then add this value at intersections. We have these 3 intersections, then there are these 3 intersections. 1, 1 plus 1 would be a 2, 0 plus 1 would be a 1. This would become a 3, 3, 1. Uncut cells, subtraction, intersections, additions and copy the remaining ones. What do we have? 1, 0, 0, 0, 0, 1. Here we have a 0, 0, 2, 4, 2, 2. Okay, here also we have some cells 0, 2, 6, 0, 0 and 0. Now let us check once again for unique, single and minimum. If you check these 3, so no chance of unique, no chance of unique. This could have been unique, but then there are in columns. These could have been uniques, but these are sharing columns. So no unique zeros. Single zeros, 3, 2, this is a single 0. This one is a single 0 in its row. Let me assign it, remove its column elements. Single is done. 2, this is a single 0. Let me make an assignment, remove its elements. I'm done with rows. Let me move to columns. 2 zeros, this is a single. In its column, in its row also it is single. This is a single in its column. Remove the row zeros. Now I am through with all rows and columns. This one has become a unique this time. 1, 2, 3, 4 and 5. Once again I am left with only 5 assignments. I need 6 assignments. So this is a degeneracy once again. How do we resolve this degeneracy? I get 5 lines. 1, 2, 3, 4, 5 assignments, 5 lines. First line would be this because there are 3 zeros here, 3 zeros here. These are 2 good lines. Then remaining what you can do is you can look for one line, another line, another line. 1, 2, 3, 4 lines and fifth line. These are the uncut cells. Now we need to proceed further. We'll need some space. I'll create that space. Let us say over here. So here are a few more vacant spaces. Now let us go ahead and resolve this degeneracy. So we have our table 4. Let this be our table 5. Table 5. Minimum in the uncut cells. 3 steps. Minimum in the uncut cell is subtracted from uncut cells. Then this minimum value is added to these intersections and remaining is copied as it is. So there is a subtraction from these, there is an addition over here, and then there is a simple copy of remaining. Plus, minus and equal to. These 3 things we need to do. So plus, for plus let us go here, subtraction. This will give me a 0 and a 0, 1, 2, 6, and this will give me 4, 4, 5 and 4. 4, 4, 5, 4, 6, 6, done. So I have subtracted 1 from all these uncut cells. I need to add this 1 to these intersections. Here I have one intersection 2, 3, 4. So this will give me 4, 4, 2 and 1. So I have added. Now let me copy these remaining cells. 1, 0, 1, 0, 0, 0, 0, 2, 2 and 4. We have a 0, 1, 1, 2, 2. Then there is a 0, 1, 0, 3, 4. And finally there is a 0 and a 0. So these are new values after trying to resolve this degeneracy. We are not sure if the degeneracy has been resolved or not. It is an attempt. Let us see. Let us explore. If you check these, there will be no unique zeros because now we have gone through row reduction, column reduction, then table 3, 4, 5. These many levels we have added zeros. So probably there won't be any unique zeros. You can see there are 3 zeros, 2 zeros, 4 zeros. Everywhere there are zeros. So there are no unique zeros. Let me check single zeros and assign them. 3, 2 zeros, single 0. Let me assign it. It was single in its row. Now I have removed its column. Now it is unique. It is unique. Single in its row and column. What about 4th row? There is a single 0. Let me assign it. Column wise also it is 0. 5th, there are 2 zeros. Leave them. 6th, there is only 1 0. Make an assignment. And remove column zeros. So now it is unique. It was single in its row. Now it is single in its column also because I have removed the remaining zeros. So I am through with all rows. Let me move to columns. This column is assigned. There are 3 zeros. Leave them. Assigned. There is a single 0. Assign it. Now it is a single in its column. I'll make it single in its row also. Done. When I check next column, there are no zeros over here. So we are through with columns. This column is assigned. All has been scanned. Let me move to rows. No zeros. This is a single 0. Let me make this assignment and then let me go ahead and remove it. So this time I have 1, 2, 3, 4 and 5. Once again I am left with only 5 assignments. This again is degenerate. I will have to cut all zeros using 5 horizontal or vertical rows, lines. This is one line. This is another line. Then this is an important line because there are so many zeros over here. This is an important line because there are 2 zeros over here. Then we can have, let's say, this line. So I have 1, 2, 3, 4 and 5th line. So I have cut all zeros in 5 lines. Remember, we have to cut these zeros also and these zeros also. All zeros, all possible zeros should be cut. Now, minimum in these, subtract minimum in these. 1, 2, 2 is the minimum. So let me go ahead and subtract it from all. So giving me 0, 2, 0, 0, 1, 2, 0, 4, 2 and 4. I've subtracted minimum in these uncut cells from all uncut cells. Then for intersections, I'll add this. there are 1, 2, 3, 4 intersections. 1 intersection, 2 intersection, 3 intersection and 4 intersections. I'll add this 2, making it a 3, 2, 3, 2. No, this is not an intersection. This will be a 0. We have first, second, third intersection, then there is an intersection over there. 4 plus 2 making it 6. Now we need to copy. It is very easy to see. These are uncut cells, these are intersections. Now remaining everything is covered by these lines. We need to copy it. What is it? 4 zeros followed by a 4. Then we have a 0, 1, 1, 0, 4. 0, 1, 1, 0 and 4. Then there is a 2, 1, 0, 1, 5. 2, 1, 0, 1, 5. We have a couple of zeros over here. Then there is a 4, 2, 1, 4, 2, 1, 0, 0. I've made another attempt at resolving this degeneracy. Let us go ahead. 2 zeros, 3 zeros, 3 zeros, 2 zeros, 4 zeros. I have a single 0 finally. And I remove its column zeros. First assignment. Let me go to columns. 3 zeros, 2 zeros. We have a single 0. This is single. Make it unique. Cut. Next column. 3 zeros, 4 zeros rather. 2 zeros. Leave them. So I have made a scan at all rows and all columns. Make another scan at rows. 2, 3, 3, 3. None of the rows has single zeros. Columns 3, 2, 4, 2. Now this is a situation of third step in priority. First in priority was unique. Second in priority was single 0. And third in priority, now there are no single zeros. Third in priority was minimum zeros. Row or column with minimum zeros. So let me check how many zeros each has. 2 and 3. So 2 is better than 3. 3. 3. So in rows I see that this 2 is minimum. Other rows are having 3 zeros. So if I were to select a row, I would select this first row and make an assignment. Let me go with columns. There are 3 zeros, there are 2 zeros, there are 4 zeros and 2 zeros. So I have a row. I have this row with 2 zeros, I have this column with 2 zeros and I have this column with 2 zeros. I need to select minimum zeros. So I have identified a row and 2 columns with minimum zeros. Of these, which one is in most need? If I see here, here and here, this is a 0 which is common to a row and a column. See, these are only common to row, these are only common to column, these are only common to column, but this 0 is common to a row also and a column also. So this is the most needy 0. I need to identify minimum zeros, row or column. I have identified. All others are having 3 and 4, but these 3 are having only 2 zeros. This row is having only 2 zeros, this column is having only 2 zeros, this column is having only 2 zeros. Of these 3 alternatives, which one is best? The 0 which is most needy. This 0 is featuring in a row also with minimum zeros, a column also with minimum zeros. So this is the 0 which I should go ahead and assign. I'll assign this 0. Now I'll make it unique. In rows I have made it unique, in columns I have made it unique. This is the concept of minimum zeros which we have learned for the first time. Then I've scanned the columns. Let me go ahead with rows. We have 3, 2, 3. In columns we have 3, 2, 3. So there is, this time on my scan I get 3, 2, there are 3 zeros, there are 2 zeros, there are 3 zeros. So I have a row and a column with 2 zeros. All others have more than 2. Either they might be having 3, 4, whatever. But as far as minimum is concerned, this row has only 2 zeros, this column has only 2 zeros. And if I look at them, what is the scenario? There is no overlap. This is the row, this is the column, there is no overlap. So you are free. If there were an overlap, as it was here in this row and column, I selected that. But this time, because there is no overlap, you are free to select any. You can select either of these, but with only two. So what I'll do is, I'll select this one, thereby removing these. I've selected this one, thereby removing all others. So now it is a unique 0. Now let me again start. 2 zeros in this row, 2 zeros in this row, 2 zeros in this column, 2 zeros in this column. Now I've scanned the complete matrix. There are 2 zeros, 2 zeros, 2 zeros, 2 zeros. Now in each row, each column that is in contention of an assignment is having 2 zeros. If this kind of situation arises, then it is a case of multiple optimal solutions. Remember, it is a case of multiple optimal solutions. Why? Because there are multiple rows and columns having same number of zeros. You can go anywhere. You have this row. I'll remove our previous marks. We have a row and a row with 2 zeros, a column and a column with 2 zeros. This is a case of multiple optimal solutions. Now you are free to select any zero anywhere, because everywhere it is 2 zeros. I'll select this 0, thereby making it unique. Make it unique. You can select any. I selected this, thereby making it unique. Now if you scan the complete matrix, there is only 1 0. So we have 1, 2, 3, 4, 5 and 6 assignments. In 6 rows, 6 columns, now I have my 6 assignments. Hence I have reached my optimum solution after 6th table. But we learned a special case over here of multiple optimum solutions. How we checked it? 2 of my rows and 2 of my columns were having more than 1 zeros. And in fact, they all were having 2 zeros. So this is a case of multiple optimal solutions. Now you can overlap these with your original table. Oh, something wrong. Okay, this one was dummy. This one was dummy. If there were a dummy, this assignment was going in dummy. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3. And this is not 12, rather. So we have a 2A, 1E. Then there is a 3D, 4C, 5B. 3D, 4C, 5B. And then there is 6 dummy. So this is superimposing my final optimum results onto my original matrix. This is the minimum solution. We were studying minimization of an assignment problem, but this happened to be an unbalanced problem. So I went on to balance this problem. And after balancing this problem, 6 rows hence, I have my best solution. I have superimposed my solution onto my table, original table. So my assignment would be, or total cost would be, second, first E at 2, second A at 4, third D at 16, fourth C at 4, fifth B at 14 and sixth dummy at 0 for a total cost of 30 and 10, 40. This is my total expense, total cost, whatever you were trying to minimize. 16 and 14 is 30 and 10 40. This is how we solve an unbalanced problem. This got a little big because there was a huge amount of degeneracy. How do we check degeneracy? All zeros were concentrated in one area. There was a complete area where there was a lack of zeros. So we could have sensed that degeneracy. In any case, this is how we solve this degeneracy problem. So this is it for our present discussion. Next time when we meet, we'll take up some more topics on assignment, some variations on assignment. Until we meet next time, do take care. Thanks for watching. Bye-bye.